Hi everyone, welcome back. So we are moving on to another question under JAMB questions that we are treating under electrolysis. Now let's look at this question together. What current will deposit 3.25 gram of zinc in 2 hours? A. 2.00 ampere, B. 3.25 ampere, C. 1.34 ampere, and D. 0.67 ampere. Remember I told you that when you want to do your calculation, write out the parameter first. By writing out the parameter, it will be much easier for you to know the type of formula you're going to make use of. So here, we're giving mass to be 3.24 gram, 3.25 gram rather. So our M here equals to 3.25 gram. And we are given time to be what? 2 hours. Remember what I told you about time? I told you that your time should always be in seconds. Now, since you are given this in hours, you need to convert these hours to seconds. Now, how do you do that? You multiply, 60 seconds make 1 minute. You first of all multiply your hours to minutes, and 60 minutes make 1 hour. So it means that you're going to multiply 2 times 60. This 2 times 60 here means you have converted it to minutes. Then you also multiply it with another 60, which means you have converted it to seconds. When you press your calculator, 2 times 60 times 60 is going to give you 7,200 seconds. So this is the time we are going to be making use of. Now, when you look at it, normally we have to calculate current. The first formula, remember, the first formula that I gave you is Q equals to IT. This should have been the best formula for it, hadn't been we were given Q. But we're not giving Q, we're only giving T here, and we are asked to calculate I. So this formula is not the right formula for it. Now, the best formula that we are going to make use of is, let's go back to that, our mass again. Our mass equals to what? Relative atomic mass multiplied by Q, right? All over number of charges times what? Faraday constant. But here, we're given T. Since we're given T, it means that, and we have to calculate I, which is the current. It means that for this Q here, we are going to replace this Q with IT here, so that we can get those two parameters. So I'm going to rewrite my formula as M equals to RAM, which is my relative atomic mass, multiplied by I, my current, multiplied by time, which is T, all over number of charges times Faraday constant. Now, this is the formula we are going to use to calculate to look for the answer for the question. Now, let's move on. So let's move on. Remember, I said this is going to be the best formula for it. Now, the next thing is we have to calculate current. So it means that we need to make this current the subject of the formula. How do we do that? You just cross multiply like this. So this will come like this, and that one will go like that. Eventually, what do we have? We have our relative atomic mass multiplied by I, multiplied by T, all equals to my mass multiplied by my number of charges, multiplied by my Faraday constant. Now, to make my I the subject of the formula, I'm going to pick these two. That means divided by RAM times T. So if I divide it like that, this, divide both sides by that, sorry. So this, we cancel this, and this, we cancel this. So eventually, I'm going to have my I, which is my current, to be equals to mass multiplied by number of charges, multiplied by Q, all over relative atomic mass times what? Time. We already have our time to be 7,200. Our number of charges, my T equals to 7,200 seconds. My number of charges, which is my N, is going to be zinc. Remember, zinc always have 2 plus. So my number of charges is 2. Then what else? My Faraday constant is always 96500 coulombs. Then my molar mass. I've been given molar mass, RAM, to be what? My RAM, which is 65. Then, which other one? Mass. We have also been given mass to be what? 3.25 gram. So the next thing is to calculate for our I. We are going to input all these figures into this formula. Let's input the figures into the formula. So my I, which is the current, is going to be what? What is my M? 3.25 gram multiplied by my number of charges is 2 multiplied by my Faraday constant 96500 all over, what is my molar mass? 65, right? Then also my time. My time is 7200 seconds. So when you press your calculator, the answer you're going to get for that is 1.34 ampere. Now, do we have that option there? 2.00, 3.25, 1.34 ampere. So the best option for this question is